Welcome to the 6th lecture of DOE. And now, within half an hour of time, we will discuss random variables and probability distribution. And I hope that some of you know what is random variable and what are the different kind of probability distribution, but some of you may not be knowing. So, as a result, what I think that there must be half an hour of discussion on this. So, let us see what is random variable. The content of presentation now is random variable and its types, probability and probability distribution, probability density function, cumulative distribution function, mean and variance of a random variable, and important distributions. Let us theoretically define what is a random variable. A random variable is a numerical variable whose measured value can change from one replicate of a random experiment to another. What does it mean? If you recall our example, what we are discussing so far, that we said that we have done experiment and we got 24 observations, and there all these 24 observations are randomized. So, the experiment was randomized. That means that in the ground clutter level A, B, C or 1, 2, 3, 1, 2, 3. So, ground clutter level 1 to 3, that is low, medium and high, and you got 6 data points, here 8 data points, here 8 data points and here 8 data points, total 24 data points. Those data points, the observed y value, this came based on certain random experiment. So, what we say, that means in this case the response variable, the detection, the signal intensity level at the when the operator is able to detect the target, this is a random variable. So, that means a random experiment, the outcome of interest of random experiment is a random variable. Okay. Now, random variable can be discrete, can be continuous. So, random variable can be discrete, two types, can be continuous. Suppose the intensity level at target detection, it can have any value. It is not that 90 or 91, it can be 90 point something or some like this. So, that is a continuous random variable. But in some cases you may find that you do not get values in between some values, like if I toss several coins, the number of heads is a random variable, random value, and its the variable is also random variable. But if I say what is the number of heads, you can say n plus 1 or 5, 10 like this. You cannot say 5.5 or 6.5 or 6.25. So, these are all counts. So, these are all discrete data, discrete random variable. So, let us see that theoretically what way we write. A discrete random variable is a random variable with a finite or countably infinite set of real number for its range. For example, number of scratches on a surface, we can say that 5 scratches, 10 scratches, 50 scratches. Proportion of defective parts among 1000 tested, I think it is number of defective parts among 1000 tested. Similarly, number of transmitted bits received in error, this number, some counts are coming. What is continuous random variable? Continuous random variable is a random variable with an interval either finite or infinite of a real number for its range. Electrical current, maybe you are measuring using the unit ampere. So, it can be having that ampere 5 to 10 ampere, anything possible, or 50 amperes, anything possible, 50.5, 50.05, 50.005, everything possible. Length of a rod, pressure exerted in a body, temperature in the environment, time taken to complete the work, voltage in electric circuit, weights, all those things, these are all continuous. So, for discrete I said the number of scratches, number of defective parts among these, number of transmitted these, but if we make proportion, what happen, it can be within a certain range, it can have many values. So, you do not write proportion, you say number. Okay. Then a random variable have a its interesting characteristics is there. What is this? I say that random variable takes some value, but in advance you cannot tell that what is that value. For example, when you toss a coin, you know that two outcomes will be there, head or tail, but before or while tossing the coin you cannot say whether head or head will come. If it is a random one and it is an unbiased one, you cannot say head will, you will see head. So, that means outcome is known, but what outcome you will get, that is not known. Outcomes are head or tail in case of toss. In case of our this detection level, that intensity range may be a 70 to 120, that is the intensity level, that is also known. But at when an operator detect through the scope whether his intensity level will be 80 or 90, that is not known in advance unless the experiment is conducted. So, then what happened, because of this nature, so unless the things are not happened, we are not in a position to know. But fortunately what happened, these can be estimated, or it can be known through certain probability distribution, because random variable, even though you cannot tell precisely what is the value, but what happen, you may say that what is the probability that the value will be less than 90, or what is the probability that the value will be 90 to 100, or if it is a discrete case, so what is the probability that the number of defective items will be 5. So, that kind of characterization is possible. So, when you talk about random variable, we associate it with a probability distribution. Now, the probability distribution in case of discrete random variable, it will be discrete probability distribution. In case of continuous random variable, it will be continuous probability distribution. Okay. Anyhow, let us theoretically define that what is probability. Probability is used to quantify the likelihood or chance that a measurement described by a random variable falls within some sets of values. A probability is usually expressed in terms of a random variable. They are basically interchangeable. When you say random variable, you definitely know that you are basically interested to know the probability distribution of the random variable. When you say probability distribution, you are basically talking about distribution of the random variable. Okay. Now, let us see one example. If we repeatedly manufacture parts, that means replicate the random experiment an infinite number of times, and 25% of them will have lengths in the interval 10.8 millimeter to 11.2 millimeter, and if y denotes the part length, and then the statement, the probability statement can be written in the following manner, that probability y belongs to 10.8 to 11.2, this interval, it will be 0.25, or probability that the y varies in between 10.8 to 11.2 in terms of 10.8 less than equal to y less than equal to 11.2, that will be 0.25. This is what is the way we define probability. Okay. Now, I will go quickly give you some of the or glance through some of the properties. For example, if we consider y is a set of real number, then the y value, the random variable value, it belongs to that set of real number is equal to 1. Its practical meaning is that the probability value can be maximum of 1, means the probability value can maximum value probability can be 1. Now, second one is 0 less than equal to P y belongs to a set of an event E less than equal to 1 for any set E. So, here what does it mean? That probability value can never become negative, it will lie in between 0 and 1. Suppose there are k number of mutually exclusive sets representing that may be k number of mutually exclusive events. So, what happened if you take sum of them and find out the probability of them, then this is nothing but finding out the individual probability and summing them. This is what is written here. If E1, E2, Ek are mutually exclusive sets, probability y belongs to this equal to probability y belongs to E1 plus probability y equal to E2 like this. Okay. So, these are the some properties which you keep in your mind, because you may require sometimes to derive some statistics or some other things. Now, as I said that random variable and probability distributions are very much close, and there are probability continuous random variable. So, continuous probability distribution and discrete random variable, discrete probability distribution. So, this probability distribution in case of continuous variable is termed as probability density function, probability density function, which we say PDF. In case of discrete, we say probability mass function, which we say PMF. I expect that you know that probability density and probability mass function. If you do not know, you go through the engineering statistics book by Montgomery, Ranger and Huvele, and you will get a fair treatment on probability distribution. For the time being, you just understand that this is what is probability PDA, probability density function. X axis will be the variable of a random variable of interest, here it is y, and y axis is the density which is function of y, and when I say that what is the probability that A less than equal to y and less than equal to b, then you are talking about the area under the curve within this range, and that is what we have written this. So, this area is computed using this formula A to B Fy dy. Now, Fy, what is this function Fy? That depends on what kind of distribution it is. If it is normal distribution, then with normal parameters we can define Fy. Okay, those things you will see later on. Another one is the cumulative distribution function. Suppose I consider a value A here, and I say that what is the probability that y value will be less than equal to A, then this is nothing but this is the area under the curve, under this curve less than A, and this is written, that means as we assume that the random variable ranges from minus infinity to infinity plus infinite. So, that is why we are writing like this, the cumulative distribution function is Fy, probability that y less than equal to a certain value y, small y, is minus infinity to y f u du, when this y ranges from minus infinity to plus infinity. Okay. So, for continuous distribution we use probability density function and also cumulative distribution function. Cumulative distribution function will be there for discrete distribution also. But interestingly, this is representing the population, the characteristics of the population. In this case y, the process model, the output response variable, that is y. This is nothing but it is basically there is a physical process, and if I say that y is like this, behaving like this, then this is what is happened, y is behaving like this, that this is a statistical process. You have converted a physical process to statistical process. Statistical process. Mean physical process is this one, so you are giving like this and some y you are getting, and statistical process here what happened, this y is this is the Fy, and this side y and this side Fy. This is one kind of interpretation. Okay. So, that means this distribution, if you know, that means you know the behavior of y. When you observe in reality, you find out what is the value, what earlier values and what will be the next value, that also you will be seeing when you get that one. But here what happened, using this past data, you know that this is the distribution. So, what happened, maybe your variable value of interest is this, and you want that your all the values will be less than this, then you wanted to know what is the probability for that the y value will be less than this may be y target value. Then this is nothing but the area under this curve, and this we must know, because sometimes what happen, suppose if y value greater than this may be a case that these all those are not will be accepted by the customer, then these are all rejects. So, you want to know what is the probability that things will be rejected. This will give you valuable information. More interestingly, this diagram is giving you what is the behavior of y, whether it is normal, normal or some exponential or something else that will come in terms of statistical distribution. So, as I told you earlier also that the distribution that or the population is characterized by certain parameters. So, if I say this population is characterized by this distribution, that means this distribution definitely have certain parameters. What are those parameters? These parameters is mu and the dispersion. If I know mu and sigma square, then I can do my analysis and I can infer about the population. So, okay. So, what is in population domain, what is this mu? Mu is nothing but the mean of the population, which is expected value of y. This we write in terms of minus infinite to plus infinite, if we consider y range from minus infinite to plus infinite, and then y f y dy. Please remember y f y dy. Suppose if I ask you what is the value of integration minus infinite to plus infinite f y dy, this is the area under the curve, this will be 1 total, complete probability, total probability is 1 only, it cannot be more. But here one more thing is added here, multiplied, y times this is the expected value, means I can say that if you do another experiment and you may say that the response value will be this is the best possible value, you are expecting that this is going to happen. Similarly, what will be the expected value of variance, that is sigma square. So, sigma square is expected value of dispersion with reference to suppose y minus mu this square. We have seen earlier in sample statistics calculation yi minus mu square by n minus 1, all those things we have written this square. This is nothing but again minus infinite to plus infinite y minus mu square f y dy. Okay. So, as it is from minus infinite to plus infinite, if you know mu and then definitely you will be able to integrate it and get the value. Suppose if you do not know mu, so then you cannot calculate the sigma square. What does this mean? Mu is the mean of the population, not mean of the sample, mean of the population. So, many times what happen, you collect representative sample, compute sample average, which will be considered as the estimate of mu, and that case you use this and get this one. Okay. But please keep in mind that population parameters are seldom known. Okay. Now, what will happen if we go for discrete random variable? See, the discrete random variable case, here y value are all some counts here, that means in the graph, in this graph, the every values, this is its location, its location is this, in between when y1 and y2 nothing is there. So, because if I say y1 is 50 and y2 is 52 or 50, sorry, y2 is 51. So, in between that 50 and 51, 51.5 is not occurring because of discrete nature. So, now in this case what happened, what is the probability that y1 y value will be y1, then this is nothing but the height of this bar, relative height basically of this bar. So, here this side probability of yj and this side y, this is giving you the probability mass function, not density function. I request you to know what is the difference between mass function and density function. Then cumulative, similarly less than equal to y, here you will be using summation. When you are going for mean and variance, you see mean here instead of integration you are using here summation I equal to 1 to n yi fyi. Here also instead of integration you are using summation. So, analogous to this, when I am saying that mean in case of continuous, expected value of y minus infinite to plus infinite y fy dy. So, when it is discrete, what you are writing, this quantity you are writing like this y I f y I and I equal to, I can say all I, all y I. And here you are not writing integration here, this integration sim part, you are writing sum, summation. Here also in case of discrete it will be sum of that all y I, then y I minus mu, I think this is y I minus mu square f y I, this f y I this. So, in place of y you are using y I, because I is ranging from 1 to a particular value n, here also 1 to particular value n, you are writing y I and function, that is PDF of y I, and here also this, then this. Actually, if the observations are identically independent identification, then this will be y I only. This will be f y. So, that means y I f y sum of I equal to 1 to n if all y are identically distributed, mean all PDF values are same anyhow, but this is the general formula. Okay. So, essentially what you know now, you know random variable, and then there will be probability distribution. So, you know that continuous probability distribution, then you know the discrete probability distribution, and you also know that some properties of probability, and we have we have seen that mean and variance, these are nothing but expected values, the expected operator you are using depending on if it is mean expected value of y, if it is variance expected value of y minus mu square, this much is known related to random variables. So, as that expectation is a very important concept here, particularly in DOE, and later on we will be using different kind of expectation. So, I want to give you a elaborate discussion on some of the important concepts where which you will be using in this particular subject. Suppose C is a constant, then what is the expected value of C? It will be C only. What is the expected value of y? If y is a random variable, it is mu. Now, then what will be the expected value of C times y? It will be, as C become constant, it will come out, it is nothing but C times expected value of y, which is C mu. If C is a constant, what is the variability of C? It is 0. What is the variability of y? We have seen that sigma square, that is the variance. Variance of y is sigma square. Variance of C is 0, variance of y is sigma square. In that case, what is the variance of C y? C times y. Interestingly, it is not C variance of y, it will be C square variance of y, C square sigma square. Now consider two random variable y1 and y2. Suppose you are summing them up and then you want to know the expected value of these two. Suppose expected value of y1 plus y2. y1 is one random variable, y2 is another random variable. Then this will be nothing but y1 plus y2. So, if y1 expected value is mu 1 and y2 expected value is mu 2, then this is the formula. Okay. Now, if I say then what is the variance of y1 plus y2? Interestingly, it will be variance of y1 plus variance of y2 plus 2 times covariance of y1 y2. This, because we are saying y1 y2 to random variable, but we have not said that whether they are dependent or they are independent or not. If they are orthogonal to each other, means they are independent, means y1 no way dependent on y2 or vice versa, then the covariance will become 0. For independent variable case, this will be variance of y1 plus y2 will be the variance of individual random variable. If y1 and y2 are independent. Okay. So, other way it will be like this. Suppose what will happen instead of plus, if I write minus here. So, it will not be minus, it will always be plus. This will be always be plus irrespective of whether you are writing plus minus here, but this will become minus. So, if two random variables are independent, then what will happen? Variance of y1 plus minus this is always variance of y1 plus variance of y2 irrespective of plus minus in here. Variance is additive. Only if they are dependent to each other, there is a covariance. Covariance means one value, occurrence of y1 value depends on y2 value also, and vice versa, then this is there is a normally you are going toward, if I read more you read more, if I read less you read less, or if I read more you read less, this kind of relation is there, then you are varying, we two are varying, either positively or negatively we are varying, that is what is covariance. Okay. So, then what will happen? This will be sigma 1 square plus sigma 2 square. If sigma 1 square is the variability of variance of y1 and sigma 2 square is the variance of y2. Okay. So, let us see some more things. Suppose y1 and y2 independent, then what is the expected value of y1 times y2? This will be expected value of y1 times expected value of y2 equal to mu 1 times mu 2. But what will happen if I want to know the ratio division? It will never become irrespective of whether y1 y2 is independent or not. Okay. So, now the last one. So, you know probability distribution, there will be discrete distribution, there will be continuous distribution. For DOE, we will be interested mostly in normal distribution, we will be interested to this, and then there will be certain sampling distribution like Z distribution, T distribution, chi-square distribution, F distribution, this under this sampling distribution will be used. But in general, when you talk about probability distribution, whether discrete or continuous, there are many probability distributions depending on the nature of the variable. So, let us see some of the continuous probability distribution: normal distribution, log normal distribution, gamma distribution, Weibull distribution, beta distribution. There will be exponential distribution, Erlang distribution, many things, many more. Now, under discrete, Bernoulli distribution, binomial distribution, Poisson distribution, exponential distribution will be under continuous distribution. Okay. So, I am changing here. Okay. Fine. So, sometimes these mistakes are good, because if you go through this and you find out that you are able to identify what mistake has taken place, that gives you more clarity, and you will be able to keep in mind that okay, exponential distribution will be the continuous distribution, it is not the discrete distribution. Okay. So, again I just conclude that in this lecture it is a very simple one. We talk about random variable, we talk about probability distribution, we talk about discrete random variables, we talk about continuous random variable, we talk about expectation from mean point of view, variance point of view, we talk about that different kinds of expected values when a constant is multiplied, then what will be the expected value in terms of mean and in terms of variance, and when there are variables they are related, what will happen to their variance of some of them, and in that manner. So, suppose if I say that what is the variance of y 1 plus y 2 dot y n, and if I say they are independent, then you will definitely say that is variance of y 1 plus variance of y 2 dot variance of y n. Now, in addition, if I say that the variance of all of them are same sigma square, then you say sigma square plus sigma square plus sigma square, then this will be n times sigma square. If I assume that all those y 1 to y n, all those variables, they have same variance component. Okay. So, in addition, you have seen that there are different kinds of distribution depending on the situation it will be used, but for DOE, design analysis of experiment, we will be mostly relying on normal distribution and other sampling distribution. In next class, I think next part 1, next class we will discuss in detail the normal distribution, very important, and the next to next class we will discuss about the T distribution, chi-square distribution, F distribution, because these are very important and they will be useful in hypothesis testing time, and also when you in estimation, when we develop the confidence interval, that time also you will require to know what kind of distribution it is, and accordingly you will do this one. Hope you have understood. You are free to email me and use the forum effectively. Thank you very much.